Well, welcome to September 1st, 2020, by Zulu time, session of Zoom for Tangerine SDR and Hamside joint workshop, or joint discussions. And my name is Dave, KV0S, and I have been doing work stuff, some programming, but a little bit of radio stuff. I did get my GPSs out and working again, and trying to remember how to run GPSD and GPSMon and all that. So, but that was one of the little projects I had recently. So anyway, we're on to the list. So I'm going to go down by the participant list that I see. Next on the list is Nathaniel into W2NAF. Sorry. Go ahead, Nathaniel.
Thanks a lot, Dave. I've just been continuing to work away at teaching, getting ready for classes, teaching, all that's going fine. Work on projects with students and my own projects, giving a presentation to a local club over Zoom tomorrow night about the personal space weather station, and just going from there. W2NF, back to net.
Fine business. Next on the list is Scotty, WA2DFI. Go ahead, Scotty.
Oh, hello there. I was just trying to think this week what I did all week, and I can't think of anything. But I guess I'm. So it's been one of those weeks, you know, where it's like been 5 minutes on this and an hour on that, and then going back and doing the 5-minute thing again, only this time it takes an hour to do it. So been trying to work with John some on the magnetometer to try and get that nailed down, and I'm not having a lot of luck because we're he's behind us, and I feel like I'm pushing him too much, and I don't want to push him. So I'm just trying to be patient to do that. Still working on the data engine, getting the IOs connected up all the way. I've got the IO schedule all figured out now, I think. Just have to actually go implement what I figured out to do. And then I worked with Tom and John a little bit on the clock module, trying to figure out what the layout is going to be of the first clock module with the GPS on it. And so we can nail down the pinout. And so we'll have enough extensions in the pinout that we can do an oven disciplined oscillator, or maybe other variants with different numbers of clock outputs. And so that's been a fun deal. And I got my slides done for DCC. I still have to make the video, pre-record the video, but I got the slides done. That deadline's coming up on the 4th, so I get that done. And I guess, you know, maybe that's it. Lots of little pieces. So back to you, Dave.
Yes, and I did like your suggestion, looking at what the Raspberry Pi radio wanted to do, suggesting the I2S instead of the I2C.
Yeah, I guess what do they call it? Wait a second. It's called a PMC, not a PMC. It's called a different interface, but it's basically an I2S streaming type interface. So, and it looks like the pins come out to the connector. So
And it looks like it does more of what he wanted to do with his audio. So anyway, next on the list, we have Dan in for XWE. Go ahead, Dan.
Okay, thank you, Dave, and hello, everyone. I worked on scripts this last week. There was a new version of the Raspberry Pi OS released on the 20th of August, and it actually broke one of the scripts, so I'm glad that I went through and did a little QA on compiling the scripts against the most recent version of the OS. I bought a kind of an El Cheapo, well, not really El Cheapo, I guess it's a Samsung SSD and enclosure for the Raspberry Pi. The Raspberry Pi 4 now has USB booting built in. It's USB 3.0, and it's a full version of 3.0. So it gives pretty good transfer rates. When it gets here, which will probably be tomorrow, I will hook everything up and see if it makes a substantial difference in the operation of the Pi. I think it will, but remains to be seen what actually happens. Anyway, that's about it from here. Back to you, Dave.
Fine business. Next on the list is Dave Whitten, KD0EAG. Go ahead, Dave.
Hello. Yeah, I've been madly trying to put together a presentation for DCC. I wasn't, entirely prepared to do so, but I'm trying to catch up. But unfortunately, it has to get done pretty much tomorrow because I have to leave town. Before that, I was mostly kind of setting fire to single board computers, I think, mostly, and still don't really know what that was all about, but I don't have the guts to go back and do it because I've destroyed enough of them. But the oh, here comes my wife. Let's see, but I made some new, seemingly much better local end boards to do testing with. And I'm probably working on a remote one now too. But I've gone through a couple iterations. Mine come back much more quickly than Scotty's do. So I've gotten a couple of iterations while we've been talking about the others. But then again, there's the occasional flaw in them that they're not always quite up to snuff. So that's what passes for life around here these days. Over to you.
Fine business. I will also mention Dave and I are working with the university about a place to place one of the magnetometers near the installation that Dolores Kip will put in. They've been delayed. They were planning to put their magnetometer in May. It isn't there yet, but could be whenever they get a chance to get here. And we want to put one of our magnetometers in that area too, so that we can compare like Jenny Jump.
Yeah, and that's probably 5 miles or less as the crow flies from my house, so it's easy to it'll be easy to work with it once we have something there.
Yep. So next on the list we have it just shuffled. We have Dev. Go ahead, Dev.
Hello, good evening, everyone. I hope everybody had a nice weekend. I think I had a nice weekend, and I'm continuing to work on my project. It's slowly, I think steadily getting to where we want to be. There is no significant progress this week, but we're continuing to work towards our goal. Thank you.
Good. Next on the list, we have Bill, AB4EJ. Go ahead, Bill.
Thanks, Dave, and good evening to you and good evening to the net. Making pretty good progress here on expanding my multi-channel support so that all the functionalities work that I had working before. So now it will run Snapshotter, Ring Buffer, Firehose, and FT8. Now I have determined it doesn't make sense to support Ring Buffer and Firehose at the same time because it's kind of illogical to do all this local storage when you're uploading everything you're collecting anyway. So, and it makes it a lot easier for file management if I can just say, well, you can run Ring Buffer or Firehose mode, one or the other. Having said that, we can also support Snapshotter running with those modes as well as FT8. So I've got all of that working. The only thing I haven't tested is uploading from Ring Buffer. I had that working before, so it's just a matter of getting that all cleaned up, and probably should accomplish that this week. And then the next thing I'm going to do after that is turn to getting Whisper working on being able to copy that. And I'm hoping we'll be able to support Whisper at the same time as all the other stuff. I think it's quite possible we can, because right now I'm running a test. I got one of the Western Digital Purple line of high longevity disk drives, and I'm running it just continuously as a test, writing and writing and writing, and the using the watchdog function of DRF to take out files that get past a certain age. The oldest stuff gets deleted, so that the hard drive is working continuously, and we're just going to run it and run it and run it and see what it does. It should last a while. I think it's designed for video surveillance systems, so I think that should work. But I've got that running with also with FT8. Two channels of FT8 and a simulation of 6 8K channels that is being done with a single 48K channel coming off the Flex. And the CPU utilization on the Odroid N2 is running about 15%. So we got a lot of headroom. So if that's the case, it should be possible to handle all of that as well as Whisper. So we're going to figure that out over the course of the next few weeks. I do need still to come up with a list of use cases for the first generation of software for the that's going to be GA. I will get that as a priority so that the FPGA programming team will have done by the time they have hardware. So back to you, Dave.
Fine business. And next on the list, we have, he's listed as David Mack, David McGaw. Go ahead, David.
Hello there. Gotten a little time in on the magnetometer. I found it's a problem with one of my two remote boards. One remote board reads the magnetometer fine as a local, and the other one doesn't. And it's actually localized down to the clock line between the board and the Raspberry Pi. So haven't found the solder bridge. I presume it's something of that sort. Clock line is not being pulled down all the way. It's got a nice sawtooth on the bottom of it. So something's keeping it from asserting properly. Hopefully I can finish tracking that down and move on with being able to be one of the remote magnetometer test sites. Been working on my Baffin Island big loop antennas. We're sending some up there to be conjugate to South Pole. We're trying to decide what radios to use. Really like to have the Tangerine SDR available, but I think the first round we'll be putting up either a USRP, or if we can get the software to do 2 channels, one of the SDR Play dual channel ones. For some reason they're behind on getting 2 channels to run on that, at least on Linux. In other words, Raspberry Pi. I'm going to post it on a Pi. Yeah, we're really looking forward to being able to use the Tangerine SDR initially in 2-channel mode, but we actually use 3 and 4 channels. So hopefully our system will be able to run 4 channels simultaneous in the relatively near future. Looking forward to testing that out. And yeah, maybe we can have a further discussion. I have some other questions on the magnetometer later, but I guess that's probably about it on this side. So
Okay,
back to Nat.
very good. And next on the list, we have Gary, AF8A. Go ahead, Gary.
Good evening, everyone. Thanks, Dave. Nothing to add for the discussion tonight. I just want to say I appreciate the fact that you guys record these. I missed last week's section, was able to obviously watch the recording and kind of get filled in. And Nathaniel, I particularly appreciated the little travelogue last week. The photos from Svalbard and McMurdo and stuff were quite interesting. Back to Nat.
Yes, I had to go on Google Earth and see if I could see the NSF on top of the look like a tank at McMurdo. And yes, you can see it in. Anyway, next on the list, we have Holman. Kim, go ahead.
Hey, good evening, all. There's nothing significant to report. I'm working with our engineers to prepare for some simple tests at Jenny Jump. So we have made some simple test equipment together, and hopefully next week or so, we'll be trying to compare signals from 2 different instruments so we can confirm the operation. Right now, we are about to start a new semester and my school is not ready yet. So in terms of technology, they are still installing new stuff there, and all the instructors are confused and lost in terms of like learning new technology, adjusting to new technology. So after that, I think I'll have much more time. So we'll be starting some testing at Jenny Jump. But otherwise, yep, that's all I have to say.
Yes, thank you. And Nathaniel, I have a new appreciation for you in that wearing a COVID mask and recording a lecture and giving the lecture all at the same time is quite a multitasking event.
Yes, it is.
Anyway, next on the list, we have Jay, WB8, SBI. Do you have any comments, Jay?
Well, good evening, everybody. No video tonight, just audio. Nothing in particular related to this group, except last time or last week, I remember last week or a couple weeks ago, I was talking about the MISRA standard, Motor Industry Software Reliability Association. And one of the guys said he was going to buy the standard to actually go buy a copy of the standard for 10 or 15 British pounds. And just want to know if that happened and if that person's
Jay,
on.
I bought it. I'm about a third of the way through reading it.
I bought a copy also.
Oh, okay. Well, anybody has any questions about it, you know, being in the automotive industry that was my entire career, I made lots of use of it. So anybody has any questions, comments, whatever, wb@sbi@arl.net. And with that, 7-3, everybody, back to net.
Very good. And let's see, next on the list, we have Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I don't have much to report. I've been working on my TAPR presentation and also the heavy load of schoolwork. Scotty, I was looking at a different window when you mentioned this, but I remember you mentioned I2S and audio, and I was wondering if that was related to me or if it was for some other person.
That was related for the magnetometer compatibility with the grape board. So we're talking about getting the RF data in from the grape board to the Raspberry Pi, perhaps using I2S rather than an I2C connection because it's a faster streaming connection.
Oh, okay.
But you might want to do that too. I don't know if that's useful for you, except you probably want to send your data to the FPGA, so they want to send their data to the Raspberry Pi. So.
Oh. Yeah. The plan was to have an I2S interface done in the FPGA to accept samples.
And we can do that.
Or either that or TDM. Probably TDM for more than 2 channels. So.
Yeah, I'm not really familiar with that, but we can do it in the FPGA as long as it's not too fast. By too fast, I mean like above 50 megahertz is too fast.
I don't believe the fastest.
I think we can even do 100 megahertz if you need to, so it's probably faster than you need.
Yeah. Okay.
Jonathan, what is the multiplexing that you're trying to do? How many channels? How many bits? What?
Oh,
sample
it's you. I see. Okay. I didn't know if it was monsters or.
16 to.
Okay. Well.
16 or 24-bit samples. 1 to 4 channels of audio.
And what sample rate?
192 kilohertz.
192. Yeah, that's very doable.
Yeah.
All right.
Very doable. I've run faster than that.
Okay, so we should go on.
Go on, Dave. Thanks.
Okay. Next on the list is Mike, AAAK. Comment?
Greetings to everyone on the conference call. Back to you, Dave.
Thank you, Mike. Thanks for being there and working with the recordings. Next on the list, we have Tom, N5EG. Go ahead, Tom.
Oh, good evening, Dave. Good evening to everybody in the group. Let's see, this last week I got DCC slides and video done. And Scotty, John, and I are going to do a tag team, so the slides and the video are pretty brief. The organic HF supports all came down this week due to bronze, birch, borer, and so we're now without HF antennas. And lastly, GNU Radio pushed out a 3.8.2 version via the repository, so Ubuntu automatically updated. I'm suddenly getting buffer problems in my out of tree module that I don't think were there before, and trying to figure out how to debug. It doesn't work the same, but I've got it up and the debugger up and running in VS Code. So VS Code can work on Linux and bring up a GDB debug session. The breakpoints don't seem to work, but other than that, I'm able to debug code. So VS Code seems like a pretty powerful tool in terms of its capabilities. And that's about it for the week.
Yes, I agree with you, Tom. I use it quite a bit, and I even have it work with all my Vim commands. So for those of you that have to have Vim. Anyway, next on the list is Tom Yardish. I think it's the last. I'm going to hit everybody. Tom, you have any comments? He's still muted, so I guess he's just listening or something. Anyway, that brings us to the end of the list, so we're open for general discussion.
Well, I got a couple of things. First, back to Jonathan. 24-bit 4-channel, 192 kilohertz sampling. That's an 18.432 kilohertz bit clock. Very, very sedate in the way I work.
That's kilohertz?
Megahertz.
18 megahertz, okay.
18 megahertz.
That's doable.
Yep.
I built I2S interfaces in Max 10s to go over 50. So
yeah,
it should be
exactly. exactly. I have too. So we got a lot of headroom there. I've done 24-bit, 8-channel 192s easily. Oh, and then the other thing I wanted to talk to Dave Witten about this problem blowing up single board computers. I'm a little scared of that, but I'm wondering if maybe the problem I'm having might be related, because I'm finding that the clock line is being overloaded by something. And the interesting thing, though, it's clearly just it must be an assembly error on one of my two boards, because one interfaces properly and the other one doesn't. But you seem to think that it had to do with how the jumpers were set. And that I really don't understand why they would make any difference.
I don't understand either. I'm not sure I wasn't wrong about that whole message. I do know that I have a bunch of dead boards.
Yeah.
But why precisely? I've essentially shorted the buses on them, it looks like somehow. But maybe I have one bad board somewhere.
Right.
Because I have a whole stack of these things that I've been going back and forth and trying all different ways. And I'm about to give up on them altogether because they're out of the same batch you're working with, but there were plenty of others that worked out of that batch. And I don't know, in a fit of pique and frustration, I sent that message out the other day, and I don't dare hook them up that way anymore. But I haven't seen it. I haven't seen that behavior. Elsewhere.
You were saying that you thought it had to do with whether the jumpers were set to local or remote. Is that correct?
That appeared to be the case, and also have it being set to address 19.
That really doesn't make sense, except if there's something funny with the address line. How you have it wired to that jumper.
I know that it's incorrectly wired there, but it shouldn't do that.
Well, now that's another point that I'll bring up. I didn't have a chance to feedback on the newest schematic, but it doesn't quite match the board either. But the only discrepancy I see is that, at least on my board, there are, I think it was stuff. Oh no, what is it? No, I'm thinking of the, I'm thinking of the other board, the local only board. No, I think this one, the way you have it wired, shown on the schematic, is correct. And it's a proper way of running the address lines, as opposed to the newer one where I was saying you got some floating lines there. This board does not have them floating. They're properly asserted.
Okay. Is that the way the boards you have are as far as you can tell?
Yes.
Yeah. So, okay, that's why that would explain why they work.
Yes. That's right.
At least sometimes.
You found magnetometer boards that blew up, SBCs, so that they don't work anymore?
Well, there is one particular culprit that I have no reason to think. I have it right here, and it has. I have three Odroid N2. One's an N2 Plus. I don't think any of them work anymore. Maybe one of them will work a little bit.
So
and I have
but by not working, you mean it doesn't boot at all, or by just the I2C doesn't work anymore?
One of them may still boot. Whether I just crashed them so hard that they corrupted the EMMCs, that's a possibility too. I haven't explored. My level of frustration's just gotten too high over time with it to keep going in that direction. The other thing is, Yeah, and I have one Raspberry Pi 3 that really seems like the bus, whatever drives the bus, the well, at least the I2C lines on the bus, it shows it behaves totally normally, except it always responds saying that there's nothing there. I then attach it to something like a scope or a small little I2C analyzer thing that I have, or any number of other things, and it behaves as one would expect it to, one would wish it to. So I can't on the same board with the same settings. So I'm just exhausted.
So
I've been working on this all summer and without much happiness.
So that's really better though, because that implies that the board you're plugging in has a problem, but you didn't burn out anything on the Raspberry Pi. Because the only way you could really burn out I2C lines is if you hook them directly to 3 or 5 volts, and then it tries to pull them down because they're open drain. So you can't really, if you hook them to ground, you can't hurt them. It won't work.
Well, I'm thinking that might be what he is experiencing. The reason that I say that is that the local remote jumper switches a fuse in and out on the is it the 3.3 or the 5 volt line?
It's
the 5 volt line. But I can understand that if you put it on the remote side, which I think takes the fuse out of line, if you've got a short from that to a control line, that could cause a driver to burn out. Whereas if you have the fuse in the way,
by putting 5 volts on it.
Yeah.
How you burn it on? Okay.
Yeah, but if you put the fuse in the way, the polyfuse will open up in a moment and probably save the driver.
Another thing I think I have observed was I made a board just as meticulously as I conceivably could, and it didn't work. It didn't, I do a preliminary, when I have the bare minimum, I use the MC9808 really is the sacrificial thing. I plug it in with that and one of the quick connectors and what it takes, the minimum, but and that worked perfectly. Then, so I built up the rest of the board and I tried it and it did not work. And so I started taking parts off the board to see, and I tried different, what I thought were suspicious regions of the board. And when I took the fuse, I think it was that filter and fuse, those 4 parts off, then it started working again.
Mm-hmm.
Some evil lurks in there. But believe me, that was the prettiest board I've ever made. It hurt so bad to tear it up.
Yeah.
But
who knows what evil lurks in the heart of the mag board?
Yeah.
Hey Dave, which schematic version was that you're working on?
Well, the one that I think. Oh, you were asking David.
No, I was asking you which
okay.
one you're having trouble with.
The boards are the boards that we're talking about were essentially that schematic that you sent me last week back. You said, it was the 0.0.10. So
right.
the 10s.
Okay.
And that schematic does match what is on the board.
Yeah. I later found all those schematics buried somewhere, but just in some completely other place that, they'd got put in some extremely, to me, illogical area of my hard drive. But
Dave, I do want to give you a little pat on the back. I have one of the simple boards. I've been running it continuously since the last week of June, and it's still working, cranking along, storing data. But it doesn't have the remoting line.
Yeah, well, I'm glad to hear that. Somewhere in that remoting is the bane of my existence, but I'm sure glad I got it to work initially.
Well, I hopefully can
And
give you some good feedback very shortly so that I see that it's my clock line that's getting mucked with.
I'd appreciate that. I'd really appreciate hearing about it because this has got me climbing the walls.
So Dave,
I'm
I
ready
think
to go back to writing software.
Dave, this is a nice anecdote for your talk.
I suppose, but just about everybody who cares has heard it. But
You don't. When everything works, you don't learn anything.
That's right.
yeah, all this weighty knowledge is bearing down on me.
Failure is a good thing, up to a point.
Well, Dave is going to talk about how a citizen science project works as part of his DCC talk, and I told him just give real life. We tried this, and here's what happened, and we tried this, and here's what happened.
Yeah, well.
Because a lot of people who haven't been around projects like this, to jump in there is scary that it's not going to work right the first time. But I mean, this is how you fix it.
Well, like the capacitor and diode on the enable line.
Yeah.
That's something that you tried, and if you hadn't tried that, I would have just tied the line high and the boards wouldn't have worked, because that's what the data sheet says it's okay to do that. Even though if you read all the fine print, it doesn't say it's okay to do that. So that's something that, I mean, you learn piecemeal when you build these things, stuff that's that will stop it from working altogether if you do it wrong.
Yep. So I think you have a wonderful example, Dave.
Mm-hmm. Hope I can.
So you're an example? Is that what you said? Dave's an example?
I know
Poster
that.
child.
Yeah.
Well, you're the first one that did anything, so we have to. You jumped out.
So that means you get all the blame, right? If you're the first one.
Yeah, sure do.
Yeah.
Things were going much better early on, but oh well. There's just too many parts, and I can't. Every time I respin this thing, I can't help but put more parts on, more resistors or more things, and I know that's the wrong way to be going. I know when I'm writing code that if my code is getting shorter, I'm making progress, because usually there's so much.
The joke was in the old days when you had TVs that were made of discrete parts, is that Zenith TVs were made, and what they did is they went in and they just start clipping parts out until it stops working. And if it stops working, they put that part back in, and then they go clip more parts out. And the idea is to get the minimum amount of parts where the thing actually works.
The cheapest set they could build.
Cheapest set they could make anywhere.
Yeah. Well,
do you remember the 17 transistor radios?
Yeah, the ones with the 5 transistors in the bottom that you shake it and they were loose.
Yeah, well, there were a lot of them. I saw a review of that phenomenon, and a lot of the transistors were either being used as diodes or just had the legs soldered together.
My sister had
If you were lucky, they were spare parts.
She had a 2 transistor radio, and I've been trying to figure out what circuit you could make that would actually give you ear level volume with only 2 transistors, and something that would actually have an antenna that would hear anything. Because you'd have to have some kind of RF amp and an AF amp, so that must have been the 2 transistors.
One transistor can do both.
Yeah, I guess, but can you get enough volume to run a speaker?
Possibly. That's a good question.
Well, maybe to run a headphone.
I did a 3 transistor radio that did.
I know I've seen the 1 transistor one with the headphone, and that's pretty cool. That it is a detector and an amp both. But
well, the people who are real masters at that were in the UK, because they were. This was the days of tubes, but they were charged by the number of tubes in their set on their radio. So they were masters of running signals 2 or 3 times through a particular.
Well, I always liked the tubes that had the dual diode plus the tetrode all in one heater. You know, they had all the elements on there.
Yeah. No, but
Yeah.
I actually, my first shortwave radio had used a 12AT7. That one was the regenerative detector, and then the other section was RFM and AFM.
Say that again. RF and
It ran the RF through it as a grounded grid, and AF through it as a grounded cathode, and separated it out. They're widely separated in frequency, so you can do.
And now if you look at it like an FT1000, there's like 2,000 transistors in the thing.
I know it.
And they just sprinkle the transistors everywhere because they cost less than a penny. And they're just, I've seen them where they use 2 transistors where they want a buffer. So they want to invert it and they invert it again and they use 2 transistors. Or they use a PNP and an NPN and they just sprinkle them everywhere.
Right.
Because they're so cheap, and in those days the tubes were so expensive.
Yeah, well, that's why I like tube equipment a lot, because it was a lot more efficient.
A lot more thought went into designing it, right?
Exactly.
Well, I was going to show the clock module block diagram if anyone's interested in that. The one that John and Tom did I show that last week or not?
You did.
Well, this is an improved one. Improved, that's in quotes. That's like Dave's improved one, This one probably doesn't work.
New and improved.
New and unimproved. It's just different and more expensive. So.
Right.
So let's see if this actually will work.
Cheaper to make, more expensive to buy.
Right. Better for us, worse for you as the customer. So does this come across as?
Yep.
You can make it a little bit bigger, and well, that didn't work very well. Well, yeah, that got all. I think I got it all there.
As long as you don't want to read the legend.
Yeah, well, John's going to make this into a slide, so you better look at it and memorize it now because you won't be able to read it when he puts it up on his presentation. It is kind of an eye chart, but it kind of shows that this box over here is the connector, the 75-pin connector, and then we kind of went through some of the IOs. And actually, this is an old version.
Yeah, Scotty, this doesn't have the latest changes John asked for.
It doesn't. So how about that one?
That's it.
That has the latest changes. This is the ping version I sent him. That other one was the PDF that was the prior one. Because he wanted the ping version so he could shrink it and grow it.
Oh, okay.
I know how that happened.
Because a lot of other than that, you'll end up, these fine lines just disappear and then you've got no connection at all.
Yeah, Scotty, I had one question. I'm confused by the acronym EXT_INT. Is that the external internal pin?
Yeah. Hey, I just used the name John gave me. External interrupt, I think, is what it's supposed to be.
Okay, interrupt. Got it.
And so the idea is if we have the PPS in and the external interrupt in, we can use those along with the 10 megahertz in down here to synchronize as many data engines as you want together.
Okay.
Not all is going through the FPGA.
That is.
Oh boy.
So you don't like going through the FPGA? You don't like 5 nanoseconds of
no, that's gonna cause a lot of jitter. That's dirty.
Well, you're not supposed to be using it for your clock. You're supposed to be synchronizing your clock with.
Right. Well, I'm also noticing the phase comparator is being run straight out of the FPGA too.
Yeah, he's using the phase comparator to adjust this 10 megahertz clock, I believe.
Right.
Where did it go? The corrected 10 megahertz. Corrected pulse per second. This one here.
Mm-hmm. Yeah, did you ask him what the difference between the PPS and corrected PPS is?
Yeah, and the only thing he said was, unless Tom, you remember, he said, well, those may not be the final names, so that may not be what it's going to be used for.
Well, that helps.
Yeah, I think my guess is that the PPS is the raw GPS PPS, and the corrected is once you take into account the error correction that you get the GPS engine, the clock edges are further apart than you would like them to be.
Right.
And so you have this sawtooth pattern coming
Yeah,
out
that,
of the GPS. And the corrected one, I think, it sends a message that allows you to undo that.
So it's less jitter, in other words.
Yes.
yeah, that's what I thought it would be, but we wanted to figure
Yeah.
out why he was
And
sending both.
the main thing I'm interested in is the fact that the oscillator drives these clock outputs directly, so
Yes,
I don't end up having the FPGA driving the clock outputs.
true.
Yeah,
That's
yeah, and that was a large problem in a previous HF unit where the FPGA directly drove
yeah.
the clocks, and we had a lot of ground bounce problems, I think, in that.
And we have the capability to do that if you want to go move some resistors around, but it's not generally the way you want to do it.
Right. A lot could be done by the placement on the FPGA, making sure that signals are isolated to particular grounds.
Yeah, I think also you can put an external logic buffer on the lines, and as long as the ground bounce or VCC bounce doesn't flip the state of the buffer will clean up a lot of that since it's powered independently of the FPGA.
Right. Yeah, and then the real when you really need it clean, you reclock it, as I was saying last time. You put it through a flip-flop.
Yeah.
Running from the master clock.
And you can use differential signaling too, which helps a lot.
Right, true. Yeah. Well.
So anyway, this is just the first.
Try it, and then you change it.
This is the first pass at it, trying to, and you know, these internal signals I'm really not that concerned with. I'm concerned with what goes in and out of here.
Yeah.
And I want these nice and frequency accurate and low jitter. So
absolutely.
Those
are the most critical, of course.
Because what these are going to do down here, this group of signals, these are just going to go to the data engine FPGA. So, I mean, if you really need critical timing, this is not your path. So,
right. That's
critical timing should stay on this board.
Yeah, and that's for the time stamping.
Right, right. And we've got 2 communications paths, one spare, one here, and they're each 4 bits. So that means we can do either I2C or SPI or UART, whichever we so desire. And we can have 2 of them if needed. And then I had some spare clocks on the FPGA. This is a differential clock at 1.5 volts. And there is another one up here. I think this is, no, that may be correct. But anyway, the idea is if you run this, and the FPGA has different banks that run at different voltages. So we place this in a 1.5 volt bank, and it goes to a 1.5 volt bank on the FPGA over here, and they are driven from and driven to the global nets on the FPGA, global clock nets. So they're very low skew across the entire device.
Mm-hmm.
So that's the purpose of these is so you could do synchronization between the FPGAs and keep the skew as low as possible.
Right.
Scotty, I have a question. Are these time pulse 1 and time pulse 2 the ones that are necessary to measure TEC, or do we have those lines coming out?
Yeah, they come from the GPS here, these time pulse 1 and 2. And
are those the ones that we use for that?
I think so, but I'm not sure. Do you know, Tom?
I'm not sure. I thought the corrections came out as a message from the GPS chip, which told you how to do the correction. I don't know what the 2 time pulses are.
I'm just wondering, I just want to make sure. I know John pays attention to that, but that's one thing that I had an interest in, is understanding how those would come out.
So you could measure TEC with the 2 receivers?
Yes. I've sat and read through the U-block kind of stuff, and it gets kind of tedious. There's an awful lot of lines in there.
Because these are coming directly from the U-blocks part, so
yes,
whatever function they serve, if it says in that data sheet, that would be it's the same function.
There's like 400 or 500 lines that could be pulled out of that chip.
Oh, geez. Okay. Well, we have a lot of lines on the FPGA, a lot of spare lines, but the question is, what are you going to do with all of them? So
Right.
it's we connect up all the ones we think we might need, and then the ones we don't use, we don't use.
Yeah. Well, and that's the problem with those, you know, the chips do all kinds of stuff that their development boards can't because they just don't bother to hook the lines up.
Yeah. And this is a relatively inexpensive FPGA too, so it's in a 169. I think this is the leaded package, so 169. It may be a FB fine pitch ball grid array though. It's one of the cheaper packages. Interestingly, it's the same family as what we use on the data engine. It's just only 8K LEs instead of 50K, and it's in a much cheaper package. Anyway, just thought I'd share that. I'm sure that'll be in John's presentation in DCC.
Very good.
Nice.
So that's all I have.
So it's power to logic / oven.
Yeah, we got 12 volts up here to go to the an oven controlled oscillator because apparently they're pretty hungry.
Yeah.
So we would run the heater off of 12 volts, and it would, when it was first heating up, it'd take a big slug of current, and then it would calm down to something lower that is more manageable. But we wanted to try that's the 12 volts is really it's the unregulated 12 volts. So it's basically the power in, which is 11 to 15. So whatever, if it needs to be regulated for the oven, it'll have to be done on this board because and that way I can provide a lot more power because it's only limited by the traces in the connectors then, and because I don't regulate it down to anything.
Yeah, the nice thing about running an oven is if you're inefficient, who cares? You're just turning the excess power into heat anyway.
Yeah. So we'll just toggle all the flip-flops in the FPGA at the same time and make it the heater.
Temperature control.
That's right.
We put these out on the ice. That would be helpful.
Yeah, it might be useful in some settings.
Yeah. Tune for random input and output.
So now we can nail the connector pin out down here. And the only one I have left to nail down is the RF module, and the leaf module. The poor leaf module is going to be starved for pins because it's going to only have whatever's left over. And when they say that's got 500 I/O pins, they lie because you can't use all of them. They have strict rules over what.
It's 500 if you use them for the right things, right?
No, actually, well, yeah, I guess it is if you don't put a DRAM on there, because if you put a DRAM on there, they tell you these 16 pins have to be ground.
Yes.
So, I mean, I guess you could count them as IOs, right? They're inputs that read 0 all the time. So I'm not sure what use that is. But the thing is, I have the 1.5 volt bank for the RAM. You can use for things like reading jumpers and switches and LEDs and pseudo-static kind of things. And because the problem is the ground bounce, so don't be turning your LEDs on and off at 2 megahertz while you're trying to read the RAM. That's the moral of the story. I found some really nice cheap bicolor LEDs, so we can have a nice Christmas tree effect on the board.
Oh, great. How about tricolor?
I always, well, you get tricolor with 2 LEDs, right? Because
well, but I mean, red, blue, green, you can get any color you want.
Yeah, you can.
Even black and white.
You can also spend a lot of money on LEDs too. Now, it turns out that these twin LEDs are cheaper than buying 2 separate LEDs of a red and a green. So.
Yeah, well, it's like anything else. It's the packaging that costs money.
Yeah. And guess what? These are 0603 packaged with 2 LEDs and 4 pins on them.
How many microamps can you put through that?
Dave will volunteer
Those are
to solder
tight.
those for you, Scotty.
Oh, I'm not going to
Thank-
solder those. A man
Thanks,
has to know his limitations.
thanks, but no thanks.
Yeah, really.
Oh, no 603. I can just barely
Yeah, but
deal
you've
with
got to solder
those.
two
But give me an
pins on each end.
0805 any day. I'm happy there.
With 4
It's,
pins, yeah.
it's an 0603 with 2 pins on each end. It's like, no
Oh,
thanks.
well, okay. Reflow it.
The
Yeah, here,
little,
I'll show you the data sheet. It's just, it will scare you if you think you're going to actually build it yourself.
even the SOT23s, the soldering them's not the problem. It's holding, getting it, keeping it in place for a moment. Because they weigh, I looked up the weight on them and they're like micrograms of the thing. And so they have so little inertia, they go flying everywhere.
Well, like any of them, you solder one tab first and that holds it in place.
Yeah, but it has a tendency to go.
Yeah, well, I've done a lot of dead bug wiring with SOT23s.
Yeah.
Yeah, it's funny because on the magnetometer, I went to add that diode on the enable pin, to do the reset.
Uh-huh.
And I said, well, I'll just use a SOT23, like a BAT54, right? It's normally 2 diodes, but they make a single diode package. And I put it on the board, and my CAD guy calls me up and says, that thing's huge. I don't have any place to put it. And we're like, it's a SOT23. It's like this, that big. And he says, no, well, look, and he shows me, we share screens. He shows me the layout. And he's right. There's no place to put it. It's too big. So we ended up putting an 0402 diode on instead of that, a single diode that I found.
Well, there are half-size packages of those.
Well, the ones
smaller than the SOT23.
Well, oh no, it's not. Yeah, it is the SOT23, but there's the ones I'm using anyway are, yeah, they're kind of 0603-ish, but they're really tiny.
How can it be kind of 0603? Because they're big, a little bit bigger.
The leads go to the pads, but the package is so tiny that.
Oh, okay. So it's a lead in 0603.
And I can't finding which end is I pretty much have to measure them to make sure I've got the right. I can't read anything that the marker on them. That's no matter what I do.
I know what you mean because we actually used red and green diodes that were out of the same family because we figured they'd be marked the same. And the green ones and the red ones one had the anode marked and one had the cathode marked. Now you figure that one out. And they got the same exact part number. One ends in G and one's in an R. And they have the markings are opposite. And so needless to say, we got all of the red ones.
Point out, R stands for reverse.
Anyway, here you go. Here's the package right here if you can see.
Oh my God.
So, and it's 60,000.
That's way different.
60 thousandths wide by 30 thousandths high.
Oh, that's nothing like the one.
That's like the 0805 attenuator that I have.
Yeah, that's nothing like what I'm talking about.
Yeah, so we'll send these over to you, Dave. You can solder them down for us.
Yeah, well, that I could, that's nice and big.
Yeah, except you forget that this is the width of a human hair right here.
Yeah, right. Right.
Maybe not quite that thick, but thin, but still. It's better than an 0402, I guess, but still, I mean, there's 2 terminals. You gotta be kidding me. I think they put this here as an insulator pad so that you don't short these 2 out.
Right.
Yeah, as often.
Well, as that's drawn, it has 4 terminals.
Yeah, 2 on each side.
Right. So it's two independent diodes. I'm impressed.
Yeah, so let's see, it's 0.8 millimeters from here to here. So center to center, what do you think these might be, 0.7 millimeter or 0.6 millimeter? That's finer pitch than the ball grid array.
Hmm. Oh, really? Yes.
It's 0.8 of a millimeter for the ball grid array.
That's
Ugh.
Now, what is
Well,
RIG? One is R and the other's IG.
What, this part number down
The
here?
colors, I guess. One diode
3-1.
red.
Oh,
Oh, it was up there before, up at the
this
top of the
is
sheet
red
there.
and IG.
Yeah, go to the top of the sheet there. True green is IG. Whatever true green
Oh,
is.
this is
Oh,
probably German, so whatever true is in German, that would be.
yeah, but it's a
Let's see.
indium gallium nitride to get true green.
True green. Well, let's see.
So I guess the regular green LED isn't real green.
Let's see.
I hadn't seen that
the
before.
red. Here's the true
There's
green.
your spectrum.
There's your wavelength of the true green.
Right.
About 520, 530.
And compared to the red, about 640. Anyway, also pretty bright too. The intensity is, where'd it go? Right here.
Means it'll mess up my sleep if I put it on the bedside table.
Yeah, yeah. Well, this is pretty 200 millicandel. that's neither one is too bad for like a 15-cent part. I can't stand LEDs that you have to look twice to see if they're on.
But look at the green.
Look at the what?
The green.
500.
500.
500 to 800.
Yeah.
Yeah.
And your eye's more sensitive to green than to red too.
Much more.
Right.
Yeah. Yeah, that's a nightlight.
Well, it won't be. We're going to not run it at 20 milliamps, so that's my excuse to. I can run it at 3 milliamps and it'll still be plenty bright.
I will mention we're just about at our time, so anybody that are time limited.
Yep. Well, I'm just rambling here, so if anyone has something important, have at it. And what do we got? DCC, Dave, in 2 weeks, right?
Yes, it'll be a week from Friday. Wait, 2 weeks from Friday, is that right? No.
So has Phil agreed to do a presentation?
He agreed, but he never sent Steve a title. So I haven't seen it yet. He may show up or he may not. I don't know.
Let's see.
Did Steve send out a revised schedule this week?
Well, there's the schedule here.
The last one I looked at, he didn't. But
So
it'll
this
be
is
on Saturday. Probably. I don't.
see. So Saturday mornings or Friday mornings mostly ham side stuff.
Right. Yeah, I was thinking it was.
No, this hasn't been updated since because he said he had all the slots filled and had more people to present than he had slots.
Right. Go
So
down a little bit.
these TBDs are all going to be all filled.
Yeah. Go down a little bit more. Or is that? It was after Michael.
That's okay. That's the.
And then Dave.
That's the end of the presentations right there. The free DV seminar. This is Saturday now.
Yeah. It's those on.
So one of these two down here?
Yeah, I think that's where he was going to put him if he got it done.
So David Rowe's going to talk about free DV 700D and 202.
Mhm.
Oh,
Yep.
okay. He's
That
been
should be
doing
good.
some new stuff.
Yeah, I don't think. By the way, the proceedings are available now. I ordered them. They're $9 plus $3 shipping, so you can get the, and it's 250 pages.
It's Lulu.
It's a Lulu print. So, but Dave, that's like double or triple the size of the biggest one I've seen previously.
Yeah.
Aren't they
Was
under?
that
Usually they're under
was it
100 pages.
was it Ackerman?
Yeah, well, his alone is like 40 pages. But it is
They,
awesome. You guys
I
see it. It is
I
amazing.
wouldn't put it past Michael. I mean, it's a place where you can put a long paper and nobody's going to complain.
Yeah.
That's always a problem in academia. You got a 20-page limit at the most.
So let's see if this schedule is any more up to date. Let me bring this over. This is the hot cheat sheet because this is off of the board list. So,
Yeah.
but this is a while ago. So this
I
is
didn't
what,
see it on there the other day.
so this isn't even as up to date as the one that's up on the net.
No, no.
So we don't have anything newer than what that is. So, but looks like some pretty cool talks.
There might be one or two that Steve will squeeze in there. But
Did Phil say what he was going to talk about or not?
I assume some of the kind of stuff he's learned. He's been working with chirp signals.
So he'd be talking on Chirp?
Yes. And he's trying to talk as much about the things he's excited about without giving away his secrets.
That's right, because he's working at that new startup that they.
Right. So, but he's been doing a lot of antenna testing in the 2 gigahertz range, and he's looking at how far can he send a chirp signal at that range.
Yeah.
And it's much longer. At least the way he talks about it, it's a lot further than he ever expected to be able.
Well, he's got some secret sauce that makes it work that he can't tell us about.
Well, it is patented, so you can go look up the Australian patent and see.
So all we need is the patent number. We're okay.
So.
Okay. Well, anybody want to see anything more of the schedule before I close it?
I don't think so.
I've been kind of scrolling past pretty fast, so.
Yeah, are there any lightning sessions?
I don't think he's got any lightning sessions programmed.
Okay.
Pretty much every session on here is a half-hour slot.
Okay.
So,
it might be very difficult to do that in a virtual conference.
yeah, I think it will be. And actually, to me, the 15-minute sessions are almost like lightning sessions. And he hasn't put any of those in.
Okay.
I'd almost rather have an extra Q&A, a longer Q&A session on some of these interesting talks.
But
you know there's going to be questions.
The other thing is there's break times and you can ask questions there too.
Yeah. Go back up to the very top. So this is the beginning of Friday. So see, John is going to talk about his 45-page paper on it when he evaluated the GPS receiver. So this is going to be a really good one to watch. And then we're going to go right into the hardware for the personal space weather station, which will be a description of the clock module he's actually working on. And then Tom and I'll do the receiver and data engine separate. And Dave Witten, I wasn't going to really say anything on the Tangerine. I mean on the magnetometer.
Mm-hmm.
Anything you wanted me to add up there? Because I didn't really want to detract from what you guys are doing, and I didn't know what that was. So
well, there's a separate slot for except that's just one of the pieces. But I don't know why they gave me a whole separate slot to fill, and you guys all
They- yeah,
crammed into one.
They've got you down here. Where did I?
It was Scotty and Tom's idea. They both didn't want to do whole talks.
I see.
Yeah, it's
Well,
not on here. It's let's see. Hold on a second.
it's on the other one.
It's on this one here.
It was at noon or something.
On Friday.
Well, it was. Well, I don't know.
Remember, the noon is Eastern time.
Oh, right. Okay.
Yeah, here
right
it is. Yeah, it's kind of a long name.
So after Jonathan's talk,
It's noon on Pacific times, Dave.
Okay. So it's what, 11? No, 10 here.
It's
I think
noon,
that's
noon PDT. Okay.
So 10 o'clock.
We're 1 hour off of Eastern, so.
So how about 1900 Zulu? You can
1400.
figure that out, right?
Yeah.
1900 Z.
That should be 1600. So it's.
And anyway, I don't know why he put my name in there, because this is really you guys characterizing and testing and getting data.
That's exactly the way I mailed him.
Okay.
The kind of it really isn't what, I said, well, I think this is going to be close to what the title might be.
Yeah.
And here's what it's, and I stuck you in there. I didn't know exactly what the shape of the thing was going to be.
You can always change the title in your talk, just a little.
I did actually already, but I don't know about changing that. It's the same thing, just not so wordy.
Now, Dave, I told you the proceedings are published, but you are allowed to upload your video, and if you have supplemental material that people might want to know, you can put it there.
Okay, well,
Like
I think
a
I will.
figure or something.
I'm going to have to talk to you about where that is, because
You should have gotten an invite directly to your inbox.
I did, but my inbox is for this is very, very full, and but if
It'll be
talk
from
to
John Ackerman.
Yeah, I think I got it, but I thought I got it from Steve Bible, but anyway, the trouble is I have to go out of town Wednesday morning, and so I have to get this done tomorrow. And
so are you on the hook for the only presenter, or are you going to share with Yeoman and Jules?
I wish I could have, but I don't know. I got the feeling. I don't know. I haven't had.
Dave do it.
They all stepped back and you didn't, and so you get to present?
That was it, but I almost couldn't do it either, but it looked unfortunately I could. By skin of my teeth, so I'll do it.
It's bad news. Unfortunately, you got the job.
Yeah, I wanted to do a nicer talk, that looked decent and made sense, but I'm afraid it's kind of a rush.
There are plenty of other opportunities.
I actually can do a decent one, but
hey Dave, if you need more time, if you're going to be back like on the weekend, we could probably give you more time. If you want.
Don't tell me that right this minute, because I don't want to be tempted. But yeah.
Steve Bible will probably string me up for offering, but
Yeah, don't say that. Yeah, I'm going to try to get it done by tomorrow night, but I would like to talk to Dave a bit tomorrow too.
Myself and Scotty are 50% of the technical team.
I see.
Well, the moderators, you mean, right?
Yeah.
So.
Yep.
I don't know if that's a good thing or not.
There's some good talks in there though. That looks good.
I'm interested in hearing what Rob Forney has to say, because he's been around for a long time and done all kinds of interesting things.
You're talking about
the one down at the bottom. I don't know how do you pronounce his.
Rob Frone.
Frone.
Oh yeah, isn't he?
I've watched his stuff.
He's at Walla Walla or something.
Yes.
Yeah. Okay.
And he was part of groups that were using some of the OpenHPSDR stuff or the Hermes Lite and doing a lot of interesting programming.
Yeah, that'll be a good one.
Yep. I'm glad he's presenting.
Now, I see the other schedule had me down for giving us control software and database, but I don't, am I not on here because I haven't submitted an abstract yet or something?
That may be the case. I don't know why.
Yes.
I'm probably there when it says TBD. That may be the slot that was. That
So
looks
did
like
you send Steve Bible an abstract of the title or anything?
No, well, not that I recall. I mean,
He won't put you in until you do.
I understand. I understand.
Yeah, I thought we had you in there.
Yeah, I know. I appear in the other schedule. I've just been so overloaded and in some sick part of the time, so I'm running behind. I'm certainly not going to have anything ready by tomorrow for this.
You were on this here on this schedule.
Yeah, if you scroll.
Yeah, on an old schedule draft I have, you were down for like near.
Yeah, I see it right up in there. 12 noon.
That spot's listed as TBD now, so.
Yeah, so probably a slot is being. And what is the deadline date on that? Tomorrow? Because I'm not going to have it by tomorrow.
The 4th. It's the 4th. It's Friday.
The presentation has to be uploaded by the 4th.
So the video, the recorded video, and the slides and whatever supplemental material by the 4th, which is the Friday before DCC. And if you wind to Steve, he'll probably give you more time because we just have to get them all lined up for being played back.
Now, I'm sorry, I'm not firing on all cylinders here. How do I record a video?
The easiest way is if you're familiar with Zoom, you start a Zoom meeting by yourself, share your PowerPoint, and turn your mic on and record that, just talking through your slides. And then that'll make an MP4 that you can send to us.
Okay. Now,
but if you're familiar with editing software, some people prefer to do it themselves.
Now that's going to be a fairly long MP4. How are people emailing those around?
Well, you upload it to a Dropbox.
Okay.
Or a Google Drive, I guess, isn't it, Dave?
Yeah, I can't remember what he was using.
Let's see, he says.
I think I got a Google Drive sent to me today.
Yeah, Google Drive. And then we're going to organize them so that everything's queued in the sequence.
And then they request that you be there for the Q&A session, which is the last 10 minutes after your slot, your time slot, the last 10 minutes of your slot.
There are exceptions for people in a different side of the world.
Well, Alabama counts, doesn't it?
It's a third world country. This is for sure. We are haven't made a lot of progress in these last 200 years.
They'll give you special dispensation.
All right. Well, I think I should be able to have something by that's Friday.
Yep.
But probably the thing for me to do is to get an abstract to Steve.
Yeah.
I'll try to do it tomorrow, but.
Yeah. Send him a message and tell him where you are. That's what he wants to know.
Especially since we're overbooked, it'd be good to get something in because then he'll take the ones that he has and put them up.
Yeah, I don't know how important this really is. If it was up to me, I would just forego doing it. But if there's a demand for this,
I think there's going to be a huge number of listeners.
Yeah, if there's a demand for a briefing on this topic, I can do it. But
because being basically a free conference, kind of like HAMSA, I mean, Nathaniel, you had 3 or 4 times the normal attendees, didn't we, for HAMSA?
Yeah, it was pretty good.
Or at least.
Yeah. Yeah, it was very good.
Yeah, I
Yes,
gave a
sir.
presentation on the very much like this to a ham radio club about 2 weeks ago. I think I can get that and update it, add a little to it, and clean it up, and take out some extraneous stuff, and have this.
Yeah,
I
that's
think
kind of what I did with mine is I took the one from a year ago and I ripped out all the extraneous stuff and then I updated all the figures and everything for the progress we made in the last year.
I think
And it was
Dave,
very
go ahead.
difficult just to narrow it down to only 11 slides because you know me. I mean, 5 minutes, that's like at least 25 or 30 slides, right?
Scotty.
To make
Zoom.
this little, help me out a little bit here. Can somebody give me Steve Bible's email address?
Sure. And I can give it to you. It is Stephen.bible@gmail.com. You want me to paste it in the window or?
Stephen.bible@gmail.com. Okay.
Here, we'll put it in the chat window here. So.
Okay, I got it. Thank you.
Okay.
I need to get out of here, so I'm going to say 73 to everybody.
All right.
I do too. So.
Yeah, me too.
Good session. 7-3, everyone.
73.
73, everyone.
73.
73.
Hi, everyone.